Okay, let's do this. My name is Ed Charbeneau. I'm a developer advocate for progress. We make UI components for everything. This is my 5th time speaking at Star Trek. I love Star Trek. Last year, I made a joke about Aquaman dying at the end of Avengers, and I got booed. It's okay, I took it well. But this isn't about me, this is about WebAssembly. So let's talk about WebAssembly into the WASM'verse. The year was 1995, and JavaScript was chosen by Netscape as its scripting language. And the reason they chose it was because it was simple, dynamic, and it appealed to non-developers. Fast forward a few years, things remained fairly simple. We had jQuery. Today, the landscape has gotten very dynamic. We've got all sorts of tools. But I would hardly call the current ecosystem something that non-developers would relate to. So the web has changed, and our needs have changed too. And today, we have a different set of things that we need to accomplish. And that is, we need speed, portability, and flexibility. And that's what WebAssembly can be. So let's talk about WebAssembly. So WebAssembly is a web standard, and it's an assembly-like format that our web pages can execute. And it can do this without plugins. So we don't need to add anything else to our browsers. They already support it. Now, if you have questions throughout the session, make sure you log into the Slack channel at 2019-OCLC and ask questions. So why WebAssembly? Well, let's get back to those 3 statements I said earlier. Speed. So we have smaller files with WebAssembly. And they're already compiled, so they decode and execute much faster. They have already been compiled, so all of the optimization has happened at compile time, outside of the browser. And we can run these at near native speeds. And what do they mean by near native speeds? Well, we can run WebAssembly about 20% slower than it would run on a CPU. Portability. We can use existing code bases that we already have. We can run without plugins in the browser. And it runs pretty much on any browser. Any modern browser supports WebAssembly, and there are polyfills that can help bridge in older browsers. Flexibility, there's more languages available, and we'll show some examples of that in a minute. And that gives us a much more diverse ecosystem. And this also can extend the capabilities of JavaScript. So if we look at a browser and how it processes things today, the parser takes in JavaScript and HTML. And then it turns that into an abstract syntax tree. It then compiles it and turns it into bytecode. And then that bytecode is just-in-time compiled, or just-in-time interpreted. And that interfaces with the APIs in the DOM. So WebAssembly, you could consider that kind of like an interface that we've opened up. And we no longer have to go through those steps of compiling and creating that abstract syntax tree within the browser. We can compile ahead of time and provide that bytecode directly to the browser. So all of the optimization and everything has already taken place, and the browser doesn't need to worry about that either. It just decodes and executes. And it also opens up the ability for us to use many different languages. So we have C, C#, C++, Go, and Rust, and many others that can compile to WebAssembly. So what does this type of code look like? Well, we could take a C file, and then we can convert that into WebAssembly. And that's kind of what WebAssembly looks like. It's not something that we would generally write directly to.
There's actually a couple versions of WebAssembly. There's one that's human readable, like this one. It's called .wat. .wasm is the type that you can't read. It's not human readable. And that can converted to bytecode. And with all this WebAssembly stuff, what happens with JavaScript? Is it like Thanos' gauntlet, where he's going to snap his fingers and half of our beloved JavaScript libraries just vanish? That's something I want you to think about during the session and answer for yourselves. So we're going to look at 3 different WebAssembly technologies, or 3 different languages that we use with WebAssembly. We have Emscripten. We also have Rust. And then we have something called Blazor. So what is Emscripten? This is actually a tool chain that's used for compiling WebAssembly. And it uses an actual stack of different technologies to do this. And it's mainly used to compile C and C++ languages and similar languages to native WebAssembly code. So let's take a look at an example. So this is a C function. And we have, if we look at lines 4 and 5, we have a function called main. And main will return 14,605,000. Is that a significant number to anybody? Testing your Marvel knowledge in here. There's a couple. You'll watch the movie later. You'll get it. All right, so this function is going to just output that number. Now, this is a C function. And we're decorating that function also with an attribute that makes it visible it makes it a public member. And then we need JavaScript to load that WebAssembly. So that's what we're going to do next. We're going to go find that WebAssembly file, main.wasm. Then we're going to pull that data out into a byte array. We're going to instantiate it. And then you'll be pretty familiar with document get element by ID. So we're going to go out to the DOM. We're going to find an element. And then we're going to set some text inside of that element. What's interesting here on line 7 is we have instance.export main. So WebAssembly is capable of using the import-export module system that we have in JavaScript. So we can call these functions from WebAssembly within our JavaScript code. So now we say text context equals whatever the result of main is. So that gets us it's going to grab our container element, and inside of that container element, we're going to have the output of 14,605,000, or the number of possible outcomes to the end game. So what can we use this technology for? Emscripten is a very powerful tool, and people have used it for all sorts of things because you can take any existing C++ or C library, and you can convert or port that code with some effort to the web. And people have actually taken the source engine for Doom 3 and Doom 3 itself and ported that over to WebAssembly. And you can run this in the browser, and it runs at pretty decent speeds. I tested it out yesterday, and I was getting about 30 frames per second, which to me is playable. So we have playable Doom in the browser thanks to Emscripten. So some pretty interesting stuff there. All right, next let's look at Rust. Rust is a C++-like language. People like it because it's fast, the file output sizes are small, and it has really great tooling. And it has really great tooling for WebAssembly as well. So it has an ecosystem called crates. These are packages. And they have several based around WebAssembly. And these are just a few that I named here in the slide. And WASM bindgen is a major one. This gives us interoperability with JavaScript. So we can do some really cool things with that. We can also map futures to promises. So this is mapping an async await behavior that Rust has with promises in JavaScript. So there's lots of packages like these. So another one, WebSys, it imports a bunch of web APIs, stuff for DOM manipulation. Okay, so you can write to WebGL and do all sorts of really cool stuff. And the list goes on. There's many, many more. These are just a couple. So let's take a look at a Rust application. So I have main BG, or bindgen. So this is my Rust file here. So I'm going to have a reference to my WASM bindgen. And I'm going to use that attribute on a couple functions. So we look at line 7. Something really important is happening here. We're actually importing the alert function from the DOM into our Rust code. So we're going to be able to call the alert function on the browser from within our Rust code. On lines 11 and 12, we can set up a greet function that passes in a parameter to that alert. And we can then say hello plus the parameter that's set. And then we have a JavaScript file that we need. So you'll notice this is a common trend throughout this talk so far, is that we still need JavaScript. And I still want you to make that decision for yourself, whether it's JavaScript is in any kind of danger or anything like that because of WebAssembly. But you'll see that there's a common theme here, that we still need JavaScript for many things. So we're going to import the bindgen stuff. We're going to run, we have a function called runapp that's going to call the greet function that we wrote in Rust and pass in world. And then finally, our application is going to bootstrap that all up, and then it's going to call that runapp function. And this is what our HTML looks like. We've got two scripts in here. Notice I have a main and a main bindgen.js. So main bindgen.js, it has emitted a bunch of helper functions that are JavaScript functions that do a lot of things to help along the code that we wrote. So it has things to get, to transfer objects across the WebAssembly boundary. So WebAssembly only speaks in integers. So if we need to send a text across, we send that as binary data. And these bindgen functions help decipher or parse that out into a text string and back and forth. It also links up that alert function. So we have that main underscore bg.js has all those helper functions in it. Those were created for us from bindgen. Then we have main.js, which has the code you see here on the left. When we put those things together, we get an alert window inside of our browser that says hello world. So we've actually communicated back and forth between Rust and JavaScript and made something really cool happen. So this is interoperability, or JavaScript interop with Rust. Next, let's talk about Blazor. Blazor has a lot of features. Blazor is a little bit more than the last two things I've showed you. The last two projects that I showed you, these are meant for compiling existing code or compiling new code to WebAssembly. Blazor takes a whole different stance at this. Blazor is an entire framework that is meant to be an alternative to Angular and React. Except Blazor works with WebAssembly, and all of the code is C#. So you can have a single-page application framework that all of the code you're writing is in C# using the .NET framework. So that's the way it was able to gain all of these features so quickly, is it's leveraging an already existing ecosystem. And it has things like dependency injection that you would find in ASP.NET Core. It has a brand new component model that they wrote that is very similar to React. It has routing, unit testing, all of the things that you would expect out of a modern front-end single-page application framework. It also has a gigantic ecosystem. So it's written on .NET, and any .NET standard package that doesn't attach itself to something outside of the web ecosystem can be used inside of Blazor. I'll give you an example. I wrote an application that used a markdown parser. I just pulled in a NuGet package and ran it right inside the browser on the client. And I'll go over how all of this works in just a minute. To expand on that ecosystem, we even have, I work for Telerik, and we have UI components that we've built for Blazor already. So we have all sorts of things, charts, graphs, grids, all the rich UI components that you would need to build a modern-day application. So what exactly is Blazor? It's a framework to write SPA applications using C# on the client. It uses web standard technologies, so there's no plugins to make this thing work. The way that they got this to work so quickly is the Mono team. The Mono team used the Emscripten tools to compile the .NET runtime. So now we've compiled an entire runtime to WebAssembly. And they're running the .NET runtime in the browser. So that allows us to use existing libraries inside the browser, inside of a runtime that we already know how to write code for. And they're all, like I said before, they're all .NET standard. So we can pull in any .NET standard library that's not dependent on some other system, and we can use that in our application. So what it's not, it doesn't need any plugins. It's not some rehashing of web forms. It's not Silverlight again. It's not transpiled into JavaScript, so this isn't like TypeScript or anything like that. So if we look at that same block diagram like we had before, we have our normal HTML, and that's going to bootstrap our application, just like an Angular or a React app would. But instead of just calling a JavaScript bootstrapper, we're also going to load in mono.wasm. So what is mono.wasm? Well, mono.wasm is the mono runtime for WebAssembly. So mono is a .NET runtime that you can run pretty much any .NET code in. The mono runtime is very stable. It's been around since the beginning of .NET, really. And it's used on many things. If you have heard of Unity before, the game engine, it's used to build AAA game titles. So Unity is a mono runtime that runs on Xbox and all sorts of things. It even runs on the web, and it has a WebAssembly output as well. But that's what's being used here. It's also used on Xamarin. So it runs on iOS and Android. So it's the same idea. They've ported the .NET runtime once again, this time to WebAssembly. So we're going to load that up into the browser. Once we have that in the browser, we can load in our DLL files. So these are actually loading .NET DLL files into the runtime inside the browser. So we don't need any special compilation steps. Our code that we write in C# isn't being compiled to WebAssembly. It's just being compiled to the .NET runtime. So these are normal .NET DLL files. They run right in the browser. So this is really cool stuff. Even if you're not a .NET developer and a .NET fan, you have to admit this is cool stuff. So we've now taken an entire runtime, ported that to WebAssembly. So we're running that in the browser, and that lets us do some really nice stuff. So I'm going to have some time to work on some Blazor demos, and I'll show you exactly how Blazor works. And again, it's a front-end web development framework. Very similar to React, so some things may look pretty familiar to you, except all of the code is actually written in C#. So I'm going to do a Control F5 here to do a quick run. And when my application starts running, we'll take a look and see what we get. Once we take a look at kind of the basics here, we'll dig into some of the code. So simple Hello World app. It's got some additional pages here that we'll look at in just a second. But I want to go into inspect here real quick. And let's make sure we can see this nice and well. And I want to focus on the network tab here for a second. And I'm going to come over and do a hard reload on my application. And when my app loads up, let's see what was sent. Actually, let's see what the browser loaded here. So we have blazor.webassembly.js. That's our bootstrapper for the application. That's our framework code. You'll notice there's a bunch of DLL files that are coming down the wire. So these are .NET standard libraries. And there's mono.wasm. There's the mono runtime for WebAssembly. So that's where all of those DLLs are getting loaded and executing in the browser. So we're actually shipping these DLLs to the client, and they're running client side. Content type for the DLLs, let's see, they are application stream. So I am aware that there are some firewall issues right now with DLL files. That is something that's pretty common, and I don't know how it's being addressed yet. But I have heard some people in enterprises talking about that. So this is how our application gets loaded. One of the things that you will notice is that we have 2.4 megs that has been loaded into the browser. That is kind of a large payload. This is something that the .NET team is working on. And they're working at not only getting this file size down, but increasing the speed of all of this as well. But that's one of the things that the team is focused on. Blazor just came out of an experimental phase last month and is still in preview. So it will remain in preview releases for some time. But still, they've made some, they've broke some really interesting ground so far. And I can't wait to see what they do with it next. One of the things that they're working on to possibly get that file size down is compiling pieces of application code directly to WebAssembly as well, things that may not need to be part of a DLL in the .NET runtime. So there's lots of avenues that they can take, and there's lots of opportunities they're working on. So now we have our Hello World app. It's gotten into the browser. We've loaded our application into the web browser. Let's see what we have. We have a simple counter. This is something you'll get with a Hello World, file new project or command line .NET new Blazor app. This is what you get. You get a counter, so I can click on a counter. I'm sure that's something you've seen a million times on the web, but this is going to be a little bit different when we look at the code. We also have a weather forecast app or page. And this is actually fetching some data and displaying it in a data table. I have a final one here called Thanos. We'll take a look at that one in a second. All right, so let's look at the counter. Let's zoom in a little bit for you guys. Make sure everybody can see well here in the theater. Make that nice and big. That's about as big as I can get it there. Hopefully you guys can see well in the back. We okay in the back? All right. All right, so this is our counter component. It's made up of HTML, and you'll notice there's some @ symbols and things in here. If you haven't worked with Razor before, it's a templating and markup language for .NET. It's very simple because you don't have to have matching opening, closing curly braces. So when you see the @ symbol, we're escaping into code. So we have things like routing baked in. So we have page, and that is the counter page. So in Blazor, every component, or everything in it, is a component. This is a component that happens to have a route, so we can navigate to it. We have some basic markup, counter, current count, and then you see @ symbol current count. So we're going to bind right there to a field called current count. So this is where we're displaying our current count. And that is backed by a field here that is an integer that initializes at 0. And then we have a function called increment count that will increment the count by 1. All of the code that you see in this functions block is C#. So all of this interactivity that you saw on the web page is done in C# with no JavaScript. So if you're a C# developer, that means you can write full stack applications now with C#, no JavaScript. It's a pretty amazing feat. So whether you're a .NET fan or not, this is really cool technology. Microsoft is just the first in this territory, but you could imagine other frameworks springing up in other languages. And as a web developer with 15 years experience, I welcome that. I'd love to see more technologies brought in to make the ecosystem better and let people be more productive in the tools that they use on a daily basis. So now we've got an application written in C# or a component written in C#. What's really cool is I have this page. If I go into my index page, this is my index component with an index route. Just because I put a route on a component doesn't mean that I can't use it somewhere else. So I can come into my index page. Let's take this survey out. And in here, I can say counter. So now I can reuse that bit of component code on my page, my index page. And if I rerun this application, now I'm going to have a counter component on my home page. Same counter component that you saw on the other route, except it's another instance. So notice that went back to 0 when I went from one page to another. Those are two separate instances of that counter component. Now, this framework is already very robust. I can do lots of things with components. If I wanted to make my counter component a little more extensible, I can. So I can create a parameter. Just do a little code shortcut there to new up a parameter. So I have a parameter of integer, and I'm going to call this count by. So now I have a field called count by, and I can say instead of incrementing by 1, let's go ahead and increment by count by. We'll go ahead and give this a default value of 1 just in case we don't want people counting by 0. That wouldn't be fun. And I've got random characters popping up because I fat fingered my keyboard. There we go. All right. If I go back to my index page, now I've got my counter. I should have a count by parameter. And I can set this to count by 10. Remember, those are two different instances, so I still have my counter that counts by 1 on my counter route. So when that page comes up, it'll count by 1. This one counts by 10, and that's how flexible and easy it is to change your component logic in Blazor. So this is some really, really productive framework capabilities that we have. Now,
let's take a look at fetch data. It's a little more complex. One of the things you'll notice here is not only do I have a route, but I have something called inject. So I can use dependency injection to bring in an HTTP client, because I need to get data from different places. Now I can go call data over the web. So I can use my HTTP client to pull in some data, and I can then take that data and apply it to a data table. So now I have some more code here. I have an array of weather forecasts. So these are .NET objects. This is a class. This is a weather forecast class. You can see it automatically highlighting here below. This isn't how we normally write code, but it's just a simple example. So we've got the class in line here. And you can see that it's a weather forecast with a date, a normal date time, which date times in C# are a little more palatable than they are in JavaScript. I will give them that. So we have date time, temperature, summary, things like that. So it's a .NET class, or as we call them, POCOs, plain old class object. All right, and we also have an initialize function that uses that HTTP client that we resolved through a dependency injection. So we can say get JSON async, and then we can say we're going to get back an array of weather forecasts. So the framework will automatically take those JSON responses and format those and parse those into a weather forecast object for us. What's nice about this is if I have the same code, the same weather forecast code on the server, I can use that on the client as well. Is there a question?
There's a question in the Slack chat. What's the relationship between Razor components and Blazor components?
Okay.
Microsoft keeps changing the names.
Yes. So it sounds like somebody's been following pretty closely. So there is a terminology called Razor components, which I haven't quite explained in this talk. I didn't plan to get there, but the framework Blazor can be ran in any instance. This happens to be a WebAssembly talk, so we're talking about running Blazor on the client. Blazor doesn't have a dependency on WebAssembly. It can run anywhere. So we can run Blazor on the server, and we can remotely talk to the browser as a thin client with a very simple JavaScript endpoint. And it uses a WebSocket to do that. At one point in time, Microsoft decided to call that method of using Blazor Razor components, which was very confusing to try to communicate to people because we're calling it Blazor on the client, but now you host it somewhere else, you run it in different contexts, and the whole framework changes names. It didn't make sense, especially considering that it's not coupled to that scenario either. We could take it and run it in Electron. Then what is it called? Is it still Blazor? Is it still Razor components? Or is it something completely different? So they decided to pivot back to Blazor. So if you hear the word Razor component or Blazor component, since that renaming has happened and they brought everything back into Blazor, one could call a component a Razor component or a Blazor component. But they've walked away from the terminology of saying it's running on the server, that's Razor components. So it's still a little confusing, but at least they've settled on something and they can move forward. It's a great question. So yeah, you can run these things in other places, and instead of using get JSON async, you might call directly to Entity Framework, or you might have some kind of local service that's running on an Electron app. Blazor is very flexible. It can run pretty much anywhere. So we're running it in WebAssembly, and if we're in WebAssembly, that means we're remote. We are disconnected from our server. We need to call things in through HTTP. So we're going to say get JSON async and parse back some weather forecasts. In this instance, instead of calling an endpoint, we're just calling a local file a JSON file. But this could be a server somewhere that spits out
a JSON response. Now, what's really cool about Blazor is that we can have this weather forecast on our server code as well. So if we have a server API that is written with the same weather forecast, we could reuse validation logic. This is all things that JavaScript developers have, by the way. They can run Node on the server. They can run JavaScript on the client. They're using one language everywhere. They have these benefits as well. Now the C# ecosystem has the same benefit. So I think no matter which set of tools you use, it's still a very good scenario for people to be able to choose which one of those sets of tools they'd like to have. So another thing that this can do is in future releases, we may not even use a JSON response. We might be able to use a binary response and just send a packet of binary code that is a weather forecast or a list of weather forecasts, and Blazor knows what that is and can decode it very quickly. That isn't in the framework yet, but it is something that's being considered. So we can take this, we'll bind this data, and when you'll notice there's an await here. So we're doing an await similar to promises in JavaScript. We're going to wait on when this response completes. When it does, the component will re-render. When it re-renders, it's going to bind the data through a for each loop to the data table. What's really nice about the Razor syntax is that we get full IntelliSense here. Since it is a compiled language, we have all of these great rich features with IntelliSense that help us, find errors and things as we write these components out. So that's how our fetch data component here works. Now that is getting data from a JSON file, so it's going to happen very quickly and immediately. We can run these remotely and get data from remote locations as well. So let's take a look at another example. We have Thanos' to-do list. What do you know? Some people's names are already checked off. So I've got this nice interface here. I could click snap, but this doesn't work. So we need to add some code here to make these to-do items disappear. So let's go take a look at the Thanos to-do list and see if we can make some changes. So there's some really cool stuff going on inside this to-do list. The first thing is we have built-in validation. So if I go back to my list, if we wanted to add something to balance in the universe, and we try to click on add name, you're going to notice that it says the field is required. So that's nice. We have built-in validation that we can call that on. This uses a validation attribute called system data annotations that is very common across the .NET ecosystem. So this is something that you would see in Xamarin and Entity Framework and other .NET platform implementations. So we have that as well. We would need to add a name here. Let's see, we've got some people on the list here. Cap's already there. Oh, look, Aquaman's there. That's cool. Gamora. All right. I don't think Captain Marvel's on there. So we can add Captain Marvel, and then that gets added to the list. So let's look at the code. This is our edit form. This is what's supplying the validation. When we click on that add to-do item, we're triggering a method onValidSubmit. There's also an onInvalidSubmit, so we can decide how to handle clicks that are valid or invalid. We're going to bind to a function called addToDo. So I have in addToDo a to-do list, add new item. So new item is just a placeholder list item, to-do list item. So it's a class object there. And we're just going to take that and add it to our list. And then we're just going to clear that item out so it can be a new person can be added to that list to blank out that field. So that's as simple as that gets. So what we haven't written here is our clear finished list, our snap function. So let's take a look here. We have in our form a button. So we have a button for add name. We also have a button for clearing this list. The button name is snap, and it has an on-click event that is clear finished. So I showed you that function below. Also in here is a disabled attribute. So this is something the framework can do that's really cool, is we can use our handy C# code to say, wherever there are no done items in the list, go ahead and just make that disabled. So there's a little bit of logic in there to toggle that button if it's using the any-link query selector or query method to say, if there's no to-do items in that list that are marked as done, then disable the button because we don't have anything to clear out. So let's go down and write some code here. So I've got a little cheat above me here, but we'll rewrite this so you can see how IntelliSense lights up. So I can say to-do list. A really easy way to do this in C# is to just set this list to another instance of the list that only cherry picks out the items that are done. So we're not going to go for each through this and do a bunch of iterations on it. Instead, we'll just say to-do list dot where, and I'm going to say where the to-do item is done. And that's going to come back as an enumerable, so we need to convert that back to a list. So I'm just going to go to that list, and I'm going to say, give me all the ones that aren't done, and then we'll make that our list. And that's going to just eliminate all the ones that are done. Okay? It's a really simple and easy way to do that. So one thing I love about LINQ, it's got that functional programming approach to doing things. So I'm going to rerun my app here. And now we should have the ability to just clear that list out very quickly. Let's navigate back to our list of to-do items and click snap. And oh, everybody's gone. All right. So this gives me a lot of tools that I already know as a .NET developer. So I can use things like LINQ and C#. I can pull in NuGet packages from all over. I've used things like Fluent Validation, Mediator. Those are all things that work inside of this context. So it's a very .NET-centric way of doing client-side development that we've never had before. And all of this is thanks to WebAssembly. This is something that we've wanted for a long time, is to be able to write C# code on the client. And I'm sure there's other ecosystems out there as well that people really enjoy writing code in that they wish they could now target the web. Yeah, we have a question.
A question from Slack. Is it significant that one button's tag is blue and the other is orange?
Yes. So somebody pointed out that one button tag is highlighted in orange. These are custom colors, by the way. So they may change from instance to instance that you see other demos on the web or documentation code. But the highlighted in orange are components. A button for a regular HTML button is going to be blue. So regular HTML is blue. I haven't added anything to the submit button that makes it a component. There's no C# logic, there's no Razor, there's nothing but standard HTML logic or HTML markup there. So if I were to add an on-click event, for example, if I gave it an on-click, and that alone, it recognizes that that needs to use a component instead. Another question?
Yeah, there's more questions.
Yeah, keep them coming. This is perfectly on schedule.
How does the screen know to re-render? Can you control that?
Yes. So how does the screen know when to re-render? Actually, the screen, quote, screen does not re-render. The component re-renders. So in Blazor, much like Angular and React, there is a concept of a shadow DOM or a DOM abstraction. So all of these components actually get compiled to a C# class, which makes them quite different from normal Razor markup. And somehow I lost my Solution Explorer, and I don't know where the heck it went, and I can't get it back. So I can dig in. I could have dug into this to show you what that tree looks like, but I can't navigate my project for some reason. It's dark in here. It's hard to see where things went. So when I have, let's go to something simple. When I have something like this counter component, these markup pieces get converted into a C# class, just like they would in React with JSX. So I actually have a class called counter that has something called a render tree. And the render tree has a graph. It's a tree-based system. And it has a node that says, I have an h1 tag with the word counter in it. I have a paragraph tag that has this text in it. It has a field that is bound to current context, and so on. Now, when there is a change, for example, when I click on the increment button, that render tree says, all right, the current count value just changed. We need to notify the browser to update the value of current count. It doesn't re-render everything. It doesn't repaint the h1 tag and all this. It only renders the piece that changed. So it's doing diffing, and it's very efficient at it. So it makes very good use of the browser's DOM manipulation. So you don't directly manipulate the DOM in this. So you do have control, however, if you find that something is not updating when you would like it to. Maybe you've called something, a function or something, or a timer, some type of subsystem that is outside of the rendering logic of Blazor. You can then call a function called state has changed, and that will signal to the component, hey, I need to re-render, something has changed, and then it will repaint the component.
Suggestion, Control-Alt-L for Solution Explorer.
Thank you.
And there's a bunch of
There it is.
coming in.
Awesome. Next.
Next question. Is it possible to extract out the logic into a separate file like an MVC or MVVM structure?
So can we take the logic out of the component and put it in another file? Absolutely. So what we can do is we could actually go in and do add new class, so new item. We don't need to keep that there. We could say new class. We could call this class something like counter base, and then we have to inherit from component. They changed some naming things on here. Component. Should be component base. Let's see if we get a, there we go, completion there. So we could move all of our code into this file. So we'd take something like this out. We'd take our counter code out and place it in that file like so. And then in our counter, we would no longer need this function block, and instead we would inherit from counter base, and that would link the two items together. I don't know if I live coded that correctly. I've still got some red squigglies there, but So the protection level needs to change here. So these need to be private. And that are actually protected. Protected will make these available to the inheriting class. There we go. So that's how you take your code out of your component. As these grow in size, you can imagine me working for Progress, Telerik. We have massive components. The data grid has many, many, many features to it. We don't want all of those features in a single file. It's very helpful to have all of that code separated out and put in other files. You're talking tens of files that we use to build up a component that's large like that. Components can have child components. They can have templates. These are all things that we don't have time to show, but this is a very featureful framework so far that Microsoft has put out. More questions?
Yeah, more questions. Are the DLLs cached on the browser or loaded each time a page is loaded?
Great question. DLLs can be cached. So something like this, let's see, let's do an inspect again. There's some really big ones that come across, and I'm trying to remember the exact name of the one that I want to call out because it's the biggest. And that one is going to be, let's see here, size. We'll sort by size. And it should be MS Core lib DLL is pretty massive. This guy is the biggest one. We could put this, it's almost a meg. So we could put that one in a CDN, for example, and cache it and only have to hit it one time. Once we do that, we don't have to ever download it again. It's not something that changes very often either. You're talking about the .NET runtime, so it's not going to change except on when a new version of the .NET runtime comes out. So that's not very frequent. It's a little more frequent these days than it has been in the past, but it's not that frequent. Another thing that we could do is we can make PWAs. So imagine progressive web applications. That gets saved to our desktop as a normal app. And those files can be taken offline. So we don't need to fetch those every time as well. More questions?
Next question. What is the browser debugging support like for Blazor?
Browser debugging support. With any of the things I showed you, Rust, C#, or C++, all of those things have very mediocre, at this time, debugging. That is not to insult the amazing work that people have done to get it as far as it has come. They have done some really amazing things. It's pretty hard to, I can try to demo this if I can remember the debugging hotkeys for Chrome. You can do the debugging, but you can only set breakpoints and see where something has gotten. Shoot, I can't remember the debug command. It's kind of annoying. You have to hit a certain sequence of keys, and then you have to close all your browsers and reopen a special link. It's not an easy process. So the better answer is it's something that the Mono team is working on, since it's the Blazor team doesn't have, that's not within their scope of work, right? They're working on the framework. The team that compiled the runtime to WebAssembly, they're doing some amazing work on getting that tool working in the browser. They're almost to the point where you can inspect values. So you can actually set a breakpoint on a DLL. You can open a DLL, find the line of code in C# that it corresponds to, set a breakpoint, and when it runs, Visual Studio will pick up that breakpoint and you can inspect that value. It's getting that close, but it's not there yet. So that's why this is still in preview. It's come out of experimental because they know they can knock that out, but it's just a matter of time to get there. Okay, so that was all the questions so far. I think we're close on time here. We're about we've got 5 minutes. I will take some more questions if you have them. While that's going on, I'll put up some resources. So if you want to see what Telerik has to offer, check out demos.telerik.com/Blazor. We have charts, graphs, and all those things. Blazor.net is where you can find the Blazor stuff. Next question.
Yeah, how do we manage global state, Redux, or alternative?
Global state is can be very simple, and you can also have things like the flux pattern. There's actually a flux pattern that's based on Mediator. So if you already use Mediator on the server, that's a Jimmy Bogard open source NuGet package. There's a state management system built atop that already. You basically use dependency injection and set up a singleton. And then you can inject that object into your component and call methods on it, take values from it, set values inside of it. Any more?
How can I use existing JS libraries with Blazor, like Bootstrap?
So there is a JavaScript interoperability layer to Blazor. So you can actually, just like I showed with the Rust demo, you can actually call out to JavaScript. So you can use any existing JavaScript that you have. You open up the functions that you'd like to call to a namespace that is on the window. So you say window.mynamespace, these functions. Once you do that, inside of Blazor, you can call something called JS interop. Let's see if I can grab that real quick. You would inject it. So you do dependency injection, and it is JS runtime. You inject the JavaScript runtime. We'll inject that as JS. Oh, I've got this one abstracted into a component. We need to do this elsewhere. So it'd be at inject JS runtime as JS. Once we have the JS runtime, we just need to go into a method here, and we should be able to call JS dot. I'm not going to remember this off the top of my head. You say JavaScript invoke, and then you specify what return types you might get back, and then you just call out the function name, and you can call that code from within C#. So that's about how you set it up, but they've changed it in the last version, so I don't remember the exact method name to call. It's a great question, though. More?
We have another question, yeah. We have 2 minutes left.
Okay, let's go.
Has there been any effort on porting authentication frameworks like Identity Server to run on Blazor? Also, does Blazor support authentication libraries?
So we're talking about the client side. So, so the question is about authentication, identity, and authorization. So most people refer to identity when they're talking about authentication in .NET to the identity framework that comes with MVC. That has not been ported over yet to where you can easily just use it. However, Blazor is a client-side technology, so authentication works just by using cookie authentication. You can integrate with Twitter auth and any type of auth service right now. You just have to manually code that yourself, which is not terribly complex. There's just no existing APIs out of the box yet. It is something that's on the roadmap, and they seem to be working on converting identity over as well. So I've seen some building blocks in place for getting identity, Microsoft Identity Framework ported over, so it's easily accessible from Blazor. Next? No more? Okay. So Blazor.net to learn more about Blazor. The demos I showed using Rust in C++ were built using WebAssembly Studio. That's a Mozilla project, which I thought was really cool. So you can go to webassembly.studio and you can it's kind of like StackBlitz or JS Fiddle, any of those things, but it uses WebAssembly, and it lets you write C# and Rust in the browser and do really cool stuff. I didn't know if I was going to have Wi-Fi, so I put them in slides, but that's where I got that from. I talk about Blazor quite a bit, so you can find more information about Blazor from me from my website, which you can find either by my name. If you can't remember my name, blazorpro.com will get you there. And that is all I have, except for one more joke. You laughed this time. I love you guys. Thank you very much.